you want to improve the fuzzing coverage of a fuzz driver in OSS-Fuzz, do you? Now, the main thing you have to keep in mind is to do this, you need to basically pick a project you have some familiarity with and have some interest in, because you're going to be spending a lot of time in the actual code of the project trying to understand it, reverse engineer it, and pick out good fuzz driver targets to improve. There's a couple of guidelines and a couple of things you can do to make this easier. So let's first pull up a chart of all of the OSS-Fuzz projects. And just a preview, we are going to be eventually looking at BZIP2 here. A quick overview of this chart is sorted by the number of fuzzers the project currently has implemented. Now, projects that have only one fuzz driver implemented simply run that one fuzz driver, and sometimes it's fairly difficult to add a second fuzz driver without adding a lot of extra code. So these projects might have some great opportunities for adding additional coverage, but let's scroll down a little bit and look at projects starting with 2 fuzzes and more. This gray bar shows how many fuzz drivers are currently implemented in OSS-Fuzz. These are coverage functions are currently hit by these drivers, how many functions are not hit by these function drivers, and roughly the percentages. Fuzz Introspector was also run, and they have another number here showing how many functions the fuzz driver coverage. And notice this number is slightly different from this due to different run times, randomness, who knows what. And then their estimate on static reachability of these 2 fuzz drivers. Currently, they say that these 2 fuzz drivers should cover potentially up to 72% of the code, with a cyclomatic complexity coverage of about 79%. Also, Fuzz Introspector gives some estimates. They think that if you implement 3 additional fuzz drivers, and this is a very rough estimate, you may need to implement fewer or more than this, you can boost the coverage from 72% up to 82% and boost the cyclomatic complexity coverage from 79% to 91%. Looking at this another way, you could say if you implement 3 fuzz drivers, each fuzz driver can cover an additional 6 functions, and potentially if you implement all 3, you could potentially cover 19 additional functions. Now these particular numbers do not sound too good, so let's scroll down and pick a slightly different project. You can see libraries, Ruby, that have huge number of functions, but for our case, I'm picking something fairly simple. Let's look at BZIP2. It currently has 2 fuzz drivers, and they recommend with implementing 3 additional fuzz drivers, you can boost the code coverage up from a 62%, maybe up to around the 90% coverage. So let's look at BZIP2. Okay, let's see what's involved in actually improving the code coverage of BZIP2 in the OSS-Fuzz project. Now the first thing to do is to install Fuzz Introspector. So let's first pull up a terminal window, and from here let's get a nice clean copy of Fuzz Introspector. Now whenever this is done, Fuzz Introspector has several variations. What you want to do is you'll want to get the OSS-Fuzz version of Fuzz Introspector built. So let's first go into Fuzz Introspector, the OSS-Fuzz integration, and basically run this build OSS-Fuzz pulls. Okay. Much of OSS-Fuzz works better at root level permissions. So to avoid the nuisance of having to run sudo all the time, I prefer just to run with root level permissions. So let's try this again. If you go into Fuzz Inspector, OSS-Fuzz integration, let's run build OSS-Fuzz pools. And here to run the Docker commands that will set up all your projects. From here, let's go under OSS-Fuzz, which is a mirror of the OSS-Fuzz project. Let's look under projects and then BZIP2. Now, many different projects implement their fuzz drivers in different ways. BZIP2 is one of the simplest, easiest ways to do it, so this won't take much involvement. Other projects basically bury their fuzz drivers somewhere in their code, and you'll have to do some combination of modifying a Docker file, getting a copy of the project outside of Docker, and copying any modified fuzz driver code into the Docker file before compiling and testing. But again, you don't have to do any of this for BZIP. But in brief, each of the OSS-Fuzz projects have a Docker file, which builds basically the project itself, and then has a build script that compiles and executes the fuzzers. Now the interesting side of this build script, if you see under build fuzzers, it takes, as you see, for file in source all.c files in the source directory and compiles these as fuzzers. So all you have to do basically is look in your source directory, which is this directory here, and any .c files you throw into this source directory become fuzz drivers. So let's look at these two sample fuzz drivers here. You've got two basically libfuzz fuzz drivers. And again, this is under OSS-Fuzz integration, OSS-Fuzz, projects, BZIP2, and there's source code here for a decompress target fuzz driver, which basically sets up an external call to a library function, basically buffer to buffer decompress with the parameters, and then calls the libfuzzer LLVM fuzz test1 input, and then gives you the data, and it's going to be the fuzzed data, and then the size of this data. There is some basic parameter shifting which modifies this data a little bit, and then dumps this data casted as character types into this function. Very, very simple, very, very easy. All you're basically doing is setting up a couple simple local variables to pass to this function, plus passing the actual fuzz data. Compressed target is a little bit longer, but you see it's basically the same procedure. You've got two calls to external libraries. These are in bzlib.h. Here's the actual parameters for these two calls. You've got a couple local variables to help you pass parameters. There's some comments about the parameter setting, basically limiting block size to 9 or below. And then some error checking code, debugging code, and basically the same thing. You should always again look for your data and size. You're passing your fuzzing data, you're fuzzing the size of this data as parameters into first the buff to buff compress function, and then you're passing it in to the buff to buff decompress function afterwards, and then cleaning up all your variables per each pass. So all we have to do basically is add another .c file in this folder and basically create our own brand new fuzz driver to get additional code coverage. So what should we add? Now there's two ways of doing this. First of all, let's go ahead and run a fuzz introspector report and see what we get. Fuzz introspector reports basically need to be run not from this project's BZIP2 directory, but from the main OSS-Fuzz directory. So let's go up a little bit first and run introspector on BZIP and run each fuzzer for just a very brief 20 seconds. We mostly care about the static coverage of each fuzzer. We're not so interested in how many dynamic analysis functions are being covered. And 20 should, again, for a very small project, 20 seconds per fuzzer should be sufficient. Now this report takes a while because it runs for every single fuzz driver. So while it is running, let me show you the alternative. Linking from the main fuzz introspector page is a large collection of fuzz introspector reports. Now you can see the address at the bar here in the top, and here lets you actually browse generated reports for a good number of projects in the fuzz introspector system for OSS-Fuzz. So let's look at BZIP. You see BZIP2 compressed target and BZIP2 decompressed target, which we looked at source code earlier, combined are reaching roughly 60% of the code, 49 functions out of the 81 functions here, and the runtime analysis showed 46 functions being covered. Now in this report, we can look at these two fuzz drivers and see exactly what coverage they're reaching, what sections of the code they are not reaching, and get a general little map. But more interestingly is the section down here under analysis and suggestions. This shows you the remaining optimal interesting functions. And these, if you remember earlier, are the three that Fuzz Introspector suggests you implement. And if you implement these three, you can get additional code coverage. Now this is where some human intuition needs to take place. You have three functions here. You've got BZClose, BZOpen, and BZRead. Again, you see the same suggestions. Implementing these fuzz drivers can greatly increase your static reach, and so forth. So what are these functions? Fortunately, you can just click on BZOpen and get an idea of what each of these functions do. This dumps us into this library function. And here we can look at BZOpen. Now here's BZOpen or BZDopen. Here's BZOpen, and you can see that BZOpen is basically just a wrapper function that calls BZDopen with a couple parameters, basically a path, and then BZDopen, which opens up a file descriptor. So judging from here, BZDopen is open with file descriptor, BZOpen is open with the file name. So let's go back and look at BZOpen or BZDopen. Okay, here's the source code for BZOpen or BZDopen. Notice what's being passed here. We're looking at, again, a pathway, file descriptor, and a mode. So what can we fuzz here? Glancing at the source code kind of gives you an idea of what this is doing. You've got basic file names. You're opening a file for particular cases. Here's what the mode variable stands for: read, write. You've got basically calls to fd open and calls to fd read open, etc. So let's go back and look at the fuzz introspector report. So from our analysis, it looks like BZD open is opening a file for reading data from it. BZD close we can interpret as pretty much the same thing as closing a file. Now isn't this pretty convenient? And now we have BZ read. So let's look up BZ read. BZ read basically takes, hey look, a file, and then a buffer and a length, and it reads from that file, calling BZ read, BZ2 read, and this again is another wrapper function. Let's see if you can find this particular function. Here's read open, here's read close, and here's read. Okay, same thing. We've got an error variable, we've got the file, we got a buffer and a length, and glancing at this code basically says we're looking at the file, decompressing it, reading it. So again, with a little bit of intuition, let's figure out what type of fuzz driver we want to implement. I bet we could probably combine all three of these into one function. We've got open file name, we've got read from that file name, and we've got close a file name. Now what's missing here? If you want to open something and read something from it, you probably need to write something. So let's do all three of these steps. Let's open a file, create a temporary file, let's open it, let's write some data into it, then let's read some data out of this function, and then let's close this function. This should let us write one single fuzz driver that hits all three of these function names, and again, hitting possibly all of the supporting functions at depth that these functions may call and use. And therefore, we should be able to build and increase our code coverage with just one additional function. So what can you do to make this easier? Now, first of all, let's go back to our fuzz introspector report. Meanwhile, this thing is finished, and it started up a web server on 0000, or basically localhost, port 8008. And you can pull up this report just by pulling up Firefox. Look at the directory listing and pull up fuzz report. And you'll notice this report looks very similar to the report we just ran. So basically it has the same recommendations, has the same code coverage, has the same suggestions for future cyclomatic complexity as our original report. So again, you can see these reports by running them yourself, and you can also see these reports by pulling up the fuzz introspector site. Of course, if you make improvements or add fuzz driver information, you'll have to run these reports to see how well your improvements are. So one other thing you can do is looking up the source code of BZIP to work with it. Now you can do this by running a git clone, or you can pull it straight off their webpage. If you look at, again, the source code for BZIP, if you're not signed in to GitHub, you're not allowed to search. But if you sign into GitHub and look up the same page, then you can do searches within each library. And here we can search for BZD open. and look up all references to BZD open, see how it's called, see the definition, see any additional information, basically find the same references I showed earlier, which you could find by browsing the source code, or anything else useful. And again, you can see the source code is defined in BZlib, we were looking through earlier. So let's step back one more time. We want to find and create a fuzz driver that opens file names and does some work on them. We don't have any code in the BZIP2 project itself, but we can also do a search inside of OSS-Fuzz libraries and see if any other libraries exist that do something similar. So let's jump to the master list of OSS-Fuzz projects and look in the projects directory and do a search for anything related to file name fuzzers in these projects themselves. So again, make sure you're logged into GitHub. Search for file names or just file name in the projects folder, and you'll get a large number of projects referencing file names. Now, you can look at any of these because again, you'll see file names are fairly common. But let's just grab, let's say this project for example, read fuzzer. This thing, if you look at its source code briefly, the key function to look at, of course, is libfuzzer test1 input, its data and size, and what it does basically is call another subfunction, fuzzer guest temp file with that data and size, and then does a number of things with it. So what does this function do? It first creates a temporary file known as generate temporary file.xxx. It then opens it up as a file descriptor, which is exactly what you need. Opens it as a file descriptor and writes some bytes into this file descriptor. After it's done, it returns this back to its main function. And in the main function, it then takes what we've written. It tries to open up the file again, and as you can see down here, it performs a read call, reading data from the function that we've read from, and then finally calls close and free. So using this source code, we can take and get a lot of what we need just from another file name fuzzer, and then turn and adapt this for BZIP2. So looking back at our virtual machine, first of all, you can run coverage reports, as mentioned and shown already, by running this Python command. The other thing you can do is, of course, use some code editor. I prefer Sublime Text to edit C files in the BZIP2 project. Let's take this code, for example, from decompress target and make a brand new file and call this BZIP2 file name. And then simply, as you can see from the code in build script, the Docker file, by simply throwing another file into this folder, we create another fuzzer. Again, this will not be as easy for other projects. And from here, we can use the source code from other fuzzers, pulling up and loading libraries to build our own fuzzer driver that does the same thing with BZIP2. To test the code, you'll want to go in the main OSS-Fuzz directory, and first of all, compile the code, you can compile this inside the Docker container simply by running this command, python run helper script build fuzzers BZIP2. This will go through, take only a few seconds, and compile all the fuzz drivers in that folder. If you want to run your fuzzer and test it out, now of course you see in this error message, this corpus directory doesn't exist. Of course, if we wanted to build a corpus of suggested files, we can of course do that, but for right now let's just use a blank corpus. So let's do a make directory, create that folder, and try this again. And finally you can see the fuzzer running. Again, for this particular case, this is simply a copy of the decompressed fuzzer. But everything you can do is basically just repeating two commands. You'll basically want to compile your code and build the fuzzer BZIP2 and test it by running it and see what type of messages it returns. And of course, check any error messages or debugging messages the compiler comes up with. Now let's look at the final code. First of all, we set up a call to the external library BZLib, and then write two calls, one for write open, one for read open. Here is basically the whole code for the fuzz driver. We set up a number of temporary variables for each of the values and parameters that have to be passed to each function. We create a temporary file, again straight out of the sample file name fuzzer, have some error checking to see if this can be opened. Once it's opened, then we call BZ2 write open and then pass it on this file and see if it can create a file handle. We write fuzzing data. Again, you see data and size into the file. Then we close the file and we call read open. Open this as a new file handle. Read some data out of this file and then close it. Here is the static code, but basically calls our test function. And then you can run a fuzz introspector report for BZIP2 and see what the resulting coverage is. This will take a minute. Okay, now here is the end of the report. Pull this up again in Firefox. Pull up fuzz report. And you see now we've reached 80% coverage, reaching 72 out of the 89 functions. We're reaching 93% cyclomatic complexity of the code and a total of 50 different runtime functions. And at this point, we know we have a new file name fuzzer, which is performing a number of things. You can improve this or spend some time working on the fuzz blockers, which are things to improve how the code is running, and also look at remaining interesting functions. And you can see, as long as we knocked out all the interesting functions, we've pretty much accomplished everything we want to accomplish. And at this point, we can only just basically improve the fuzz drivers of this particular project, or else go on to a new project.